Thanks.
Don't celebrate her, I might.
Wait, is it hard?
No. Okay. Number one. Number one, it's asking for what's the y-intercept. Okay, here's a question. What is true about, what is a y-intercept? Let's start with that. What is a y-intercept?
Oh wait, where it cuts across the y-axis.
Where the graph hits the y-axis. That's the y-intercept. And everything we do, it's pretty much going to hit one time. So if this was my graph, the y-intercept would be 0, 1. Or you could just say the y-intercept's at 1. Okay. If it crossed down here, like let's say it was this line, the y-intercept would be 0, -3. Shh. Okay, what do you guys think is true about all y-intercepts?
They cross the y-axis.
Okay.
It's always 0.
The x value is always 0 because anywhere you go on the y-axis, this is like 0, -1, 0, -2. So to find a y-intercept, you can just put 0 in for x. Okay? To find the y-intercept, you don't have to graph it. You just put a 0 in for the x value and see what the y value is that comes out. So it's kind of like when we did the table, you just put a 0 there. We're not going to make a table, but on number 1, it says 1/4 x squared. So if I put a 0 in for x, what's going to come out for y? 0. X squared, 0 squared is 0 times 1/4 is 0. So when x is 0, y is 0. So the y-intercept would be 0, 0, the origin. Okay, on number 3, what's it say? 3x squared minus 5. Okay, what if I put a 0 in for this x? Right, this kind of goes away, this term just becomes 0. Minus 5 is -5. So 0 for x.
But it had an x. Oh wait, I'm looking at the wrong one. I'm sorry.
Alright. Hopefully you guys start to see a pattern here. You don't even have to think about it that much. Number 5, 3x squared minus 2x plus 1. Okay, what if we put a 0 in for the x's here?
Plus 1.
Right, that would be 0, 0, plus 1 is 1. So, do you guys see the pattern yet?
Yes.
So all these terms with x's just kind of go away when you plug a 0 in. So it's just this last term is basically the y-intercept. +1, -5, so on. It's kind of easy peasy. Actually, I say that and then they switch. Number 7's different, so. Number 7 is in vertex form. This is what we were doing yesterday. So if I plug in 0, it's not going to work.
It's x minus 2.
Yeah.
Okay. X minus 2 squared. So if I plug in 0 on this is not going to go away. That's a little different. This is standard form where you just have x squared, x in the number. This is vertex form because it tells me the vertex is at 2, 4. But anyway, it's a little harder to find that y-intercept. If I plug in 0 for x, 0 minus 2 is -2. -2 squared, -2 times -2 is 4, plus 4 is 8.
You ever watch SpongeBob, Mr. Jordan?
I have seen it before, yep.
What cartoon?
Sure, I don't really have a favorite. Because I'm not 7. No, I'm just kidding.
Well, I'm 13. You're 14, actually. I'm actually 15. I know you were 14. I'm 15.
Gavin, you don't even have to 6 years.
All right.
You don't even have to drive
If we plug in 0 here, you could do this on a calculator. 0 minus 1 is -1. -1 squared, exponent comes before multiplied. -1 squared is +1 times 2 is 2. 2 minus 7, -5. Alright, now 11, the bells aren't going to be right this morning. We actually get out like a normal schedule, so at 10:40.
I think packing should have gotten an award.
For what?
I definitely should have gotten an award. I should have gotten
Alright, number 11. The directions change. Yeah, this part you actually have to use your brain, so. Okay, well, first off, we need to define what are zeros. So, on 1 through 10, we were doing y-intercepts, right? So, the zeros are of the function are where the function, the x values that make the function equal 0. Or in other words, it's the x-intercepts. Okay, let's say I had this parabola going through, there and there. So the x-intercepts are 1, 0, right? And -2, 0. Okay. -2 and 1 would also be called the zeros of the function, because when you plug -2 or 1 into the function, it looks something like this, it should give you 0. Okay, so the zeros of the function are also the x-intercepts. It's where it crosses the x-axis at. So I just made up a graph. This does not go with number 11, by the way. This is separate. If it crossed through -2 and 1, those would be the zeros of the function. They would be the numbers that when you plugged it in, made all this equal 0. Okay? Does that make sense?
Yes.
Anytime it hits the x-axis, the y value has to be 0. Kind of like when it hits the y-axis, the x value is 0 on the problems we just did. So the zeros of the function are also the x-intercepts. It's the values that you plug in for x to make the function equal 0. So what we need to do for 11 is just set this equal to 0 and solve it. They're not going to make us graph these. Maybe if we did the next section, they might. Well, like 25 through 34. But we're going to solve this. Now, we've actually learned a couple different ways to solve this. What were the 2 ways we learned to solve this equation? Huh? Do you remember what that was called? Factoring. You can solve by factoring. That was probably like last Monday or something. That was the first lesson we did this chapter, is factoring. The other way was,
FOIL.
we did this a lot, quadratic formula. Okay, probably, well, 1 through 14 they all factor. Okay, so how does this factor? You guys remember doing this? Okay, if you're not good at factoring, you can use quadratic formula. Sometimes factoring doesn't work at all and you have to use quadratic formula. So if you want to do quadratic formula, what's the A, B, and C? 1, -2, -8. You did that like twice last week, right? Here's the formula, still up here. So if you did well on that assignment, if you're good at factoring, it's actually faster. What multiplies into -8? that adds up to -2. 4 and 2, but how do I get them to add up to -2? 2 minus 4, right? And then we said, what x values, if I plugged them in, would make these factors equal 0? 4 and -2. And if you use quadratic formula, you should get the same answers. So you can kind of choose what you want to do. If you're not sure how it factors, just go ahead and do quadratic formula. Oh, 13's weird. I guess I didn't see that one. So 13, so you just set it equal to 0. It's kind of like they already factored it for us. What does x minus 3 squared mean? It just means x minus 3 times x minus 3 equals 0. So what values of x would make these equal 0? 3. Okay, that's the only answer on this one, just 3. On the graph, what does this do to the graph of a parabola? What's the minus 3 do?
Makes you go 3 to the right.
Makes it go right 3. So on the graph, it would just be a parabola that hits the x-axis at 3. Like the vertex would be at 3, 0. So it's the x-intercept, 3, 0. It's also the 0 of the function because it's what makes the function equal 0. It's usually kind of confusing. Do you guys understand what I'm saying?
Yeah.
On the graph, it's where it hits the x-axis, and it's also the value that when you plug it in, makes the function equal 0. All right, it's called the 0 of the function. I actually want to do one more, sorry. 15 and 16. It won't kill you. Death by algebra. Okay, so this is number 15. I'm going to set it equal to 0. How could I solve this for x? Any guesses?
Start by adding 2 to both.
Adding 2. Yeah, we did stuff like this when we completed the square. You want to get this by itself first. So how can I do that? Get rid of the minus 2 first, and then the times -2 next, right? So add 2. That goes away.
Indeed.
And then how do I get rid of this -2?
Divide by.
Divide. The -2 is multiplied to the parentheses, so we can get rid of it by dividing. It goes away. Okay, we get -1. How did we get rid of this square? You guys remember?
Square root.
Square root. Okay, but what's the square root of -1?
You can't do that.
It's not real. Something called imaginary number. So this one is not going to work. So we're just going to put no real solution. Because you can't do the square root of negative. If you tried to plug it in your calculator, do you guys know what your calculator would say?
Syntax error.
Your calculator would just explode. No, it would say error. Yeah, you can't do it.
My calculator would just.
It's a good value.
So you just hit equals and you launch it. And it's grenade.
Calculator. I'm gonna use that.
Wait, what? Can we get a bonus for you, please?
Bonus?
You should make.
So what are we going?
You can do 20 for bonus if you want to.
So what are we're doing 16?
Yeah, let's go to 16. 16 is very similar. You just do x squared plus 3 equals 0. Solve for x. It seems actually easier, I'd say.
Mr. What?
16 is a lot.
John.
Hey, John.
Did you know?
That would work.
Did you know?
Mr. Jordan.
Yeah.
How would 14 work?
Oh, well,
Like 4 left. I have 4.
okay, there is a way to factor 14, or you could use quadratic formula. But if I was doing it, here's what I would do. Okay. It's easier to factor when this is not negative, so how could we get rid of a negative?
By dividing everything by negative 1.
Yeah, and what happens when we divide? So you can only do that trick when there's like an equation, you do it to both sides. What happens if I divide 0 by negative 1? Still 0. So if you divide by negative 1, you just get that.
Wait, so that's for quadratic?
Well, if you want to do quadratic, you could use negative 1, negative 6, negative 9. Or you could use 1, 6, and 9. They actually,
matter.
it works both ways. Or you could just factor this right here.
Okay.
20, you have to use quadratic formula on 20 because it doesn't work. It doesn't factor.